Hello everyone, welcome back to my channel. In this video, I'll be discussing some more SRE interview questions. So let's start. First question is, how do you handle and mitigate the incidents that are caused by third-party dependencies or external services? You can answer to this question as, to handle and mitigate the incidents caused by a third-party dependency or external service, I follow a structured approach. The first point would be monitoring and alerts. Continuously track the third-party services using monitoring tools and set up alerts for anomalies. Second point would be incident triage. Quickly assess the impact, identify the root causes, and escalate to the vendor if needed. Third point would be fallback mechanisms. Implement retries, circuit breakers, and graceful degradation to minimize disruptions. Fourth point would be communication. Keep the stakeholders informed with regular updates and work closely with the vendors for resolution. Fifth point would be post-incident review. Conduct RCA, document learnings, and implement improvements like redundancy or alternative providers to enhance resilience. This ensures minimal downtime and a proactive approach to incident management. The second question is, what role does documentation play during an incident and how do you ensure that it is accurate and helpful in the moment? The answer to this question is, documentation is critical during an incident as it provides clear steps for troubleshooting, reduces the resolution time, and ensures consistency. To keep it accurate and helpful, we follow the following steps. Keep it updated. Regularly review and refine incident runbooks based on past incidents. Second point would be make it accessible. Store documentation in a centralized, easily searchable location. Third point is keep it concise and actionable. Focus on step-by-step instructions, key contacts, and decision trees. Fourth point would be real-time updates. During an incident, log key actions, findings, and resolutions for immediate and future reference. Fifth point would be post-mortem review. Improve the documentation based on incident learnings to enhance the future response efficiency. The next question is, how do you manage incidents that are intermittently occurring, for example, sporadic latency or partial outages? You can answer to this question as, managing intermittent incidents requires a systematic approach to detection, diagnosis, and resolution. First point would be enhanced monitoring and logging. Use fine-grained metrics, distributed tracing, and log correlation to capture patterns. Then comes pattern analysis. Identify trends in occurrence, for example, time, load, dependencies, to narrow down root causes. Next point would be controlled experimentation. Test the hypothesis in a controlled manner, for example, A/B testing, canary releases, to isolate the issue. Next point would be automated recovery. Implement self-healing mechanisms like retries, fallbacks, and circuit breakers. Collaboration and RCA. Engage cross-functional teams for deeper analysis and document findings to prevent recurrence. This ensures faster detection, better mitigation, and long-term stability. The question is, how do you decide when to escalate an incident to higher levels of support or external teams? You can answer this question as, escalation is based on impact, urgency, and resolution progress. I escalate when there is a business impact, or a resolution is stalled, or an external expertise is needed, or a wider coordination is required, or an SLA or compliance is at risk. For business impact, the critical systems are down, affecting the users or SLAs. For resolution, initial troubleshooting doesn't yield progress within a set time frame. For external expertise, the issue involves third-party services or requires specialized knowledge. For wider coordination, cross-team collaboration is necessary to implement a fix. For SLAs and compliance risk, delays could lead to breaches of regulatory or contractual obligations. With this, I ensure timely escalation while maintaining clear communication to minimize the downtime. The next question is, can you describe your experience with post-incident improvements and how do you incorporate those into day-to-day operations to reduce the future risks? You can answer this question as, post-incident improvements are key to preventing recurrence and strengthening system reliability. My approach includes, first is root cause analysis, conduct detailed postmortems to identify underlying issues. Second would be actionable fixes, implement permanent solutions like code fixes, automation, or infra changes. Third point would be process enhancements, update runbooks, monitoring, and alerting to detect issues earlier. Fourth point would be knowledge sharing, conduct team reviews to ensure awareness and preparedness. Fifth point would be continuous improvement. Track and prioritize the learnings in the backlog for proactive risk mitigation. This ensures a resilient and learning-driven approach to incident management. The next question is, what are the key components of an observability stack? The answer to this question is a robust observability stack includes: first is metrics, quantitative data, that is latency, error rates, and resource usage for real-time monitoring. Second is logs, detailed event records to trace issues and debug failures. Third is tracing, end-to-end request tracking across services for performance analysis. Fourth is dashboards and alerts, visualization tools, and proactive notifications for quick response. Fifth is correlation and context, linking logs, metrics, and traces for deep insights. A well integrated stack enables faster troubleshooting and proactive system reliability. The next question is, what tools have you used for monitoring and alerting? For example, Prometheus, Grafana, Datadog, etc. You can answer to this question as, I have an experience with a range of monitoring and alerting tools, which includes Prometheus and Grafana for real-time metrics collection, visualization, and alerting, Datadog for end-to-end observability and built-in integrations for logs, metrics, and traces, New Relic application performance monitoring, APM, and distributed tracing, ELK Stack, that is Elasticsearch, Logstash, and Kibana for centralized logging and log analysis. Then cloud native tools such as AWS CloudWatch, Azure Monitor, and GCP Operations Suite for cloud monitoring. Then PagerDuty for incident alerting and on-call management. I choose tools based on scalability, integration needs, and business requirements to ensure reliable system monitoring. Next question is, how do you create effective dashboards for monitoring system health? I create effective dashboards by, first is defining key metrics, focus on business critical and system health indicators. Second is simplicity, keep visuals clear and intuitive layouts with intuitive layouts and minimal noise. Third point would be real-time data, ensure dashboards update in real-time data. Fourth point would be actionable insights, use alerts and drill down options for quick troubleshooting. Then comes user feedback, iterate based on team input and evolving requirements. The next question is, explain the difference between monitoring, logging, and tracing. The answer to this question is, monitoring, logging, and tracing are key pillars of observability. First is monitoring, which tracks the system health using metrics such as CPU latency or error rates to detect anomalies and trends. Then comes logging, captures detailed event records for debugging and auditing, helps understand what happened. Then comes tracing, follows requests across distributed systems, identifying performance bottlenecks and dependencies. Together, they provide deep visibility, enabling proactive issue detection and faster resolution. The next question is, how would you go about detecting and mitigating anomalies in real-time production traffic? You can answer to this question as, to detect and mitigate anomalies in real-time production traffic, I follow a proactive approach. First point would be implementing monitoring and alerts. Use tools like Prometheus, Datadog, and CloudWatch to track key metrics such as latency, error rates, and traffic spikes. Then comes anomaly detection. Leverage AI ML based anomaly detection or statistical thresholds to identify deviations. Third point would be automated mitigation. Use circuit breakers, error rate limiting, and auto scaling to handle anomalies dynamically. Fourth point would be real-time logging and tracing. Correlate logs and traces to pinpoint root causes quickly. Then comes incident response and post-mortem. Act fast, document the findings, and implement fixes to prevent recurrence. This ensures minimal downtime and a resilient production environment. Next question is, what is the difference between metrics and logs? How do they complement each other? Now, metrics are numerical data points collected over time, for example, CPU usage, request latency, for monitoring trends and system health. Logs are detailed, time-stamped records of events, for example, errors or transactions that are used for debugging and auditing. How they complement each other? Metrics detect anomalies quickly, triggering alerts. Logs provide context and granular details for root cause analysis. Together, they offer a complete picture of system behavior, enabling faster issue detection and resolution. The next question is, can you explain how distributed tracing works and why is it important? The distributed tracing tracks requests as they flow through a distributed system, assigning each request a unique trace ID and breaking it into spans representing different service interactions. These traces help visualize request paths, latency, and bottlenecks. Now, why it is important? First point is pinpoints the performance issues. It identifies slow services and dependencies. Next point would be improves debugging, helps correlate logs and metrics across microservices. Then comes enhances observability. It provides a full end-to-end view of request flow. Tools like Jigger, Jipkin, and OpenTelemetry can make the tracing seamless, ensuring faster troubleshooting and better system reliability. Thanks for watching my video. I hope this video was helpful. If you find this helpful, please do like, share, comment, and subscribe to my channel.